Hey guys, I'm back with another tutorial of Arduino, and in this video I'm gonna make a traffic light control using the Arduino UNO board, a breadboard, red, yellow and green LED for the vehicles, red and green LED for the pedestrians, 220 ohms for all the LEDs, that is red and brown resistor for all the 5 LEDs, a 10 kilo ohm resistor for the push button, which is brown, black and orange, some connecting wires and a USB A to B cable. So come, let's get started. So first I'm going to connect a push button at the middle of the breadboard. Connect it to the leftmost side so that we will get ample amount of space for connecting the 5 LEDs. So I'm going to connect the vehicle LEDs first. So let's keep the positive terminal of LED on the right hand side and negative terminal, that is the short side, on the left hand side. So leave one pin space for all the LEDs so that it looks good. Okay, so now I'm going to connect 2 more LEDs for the pedestrians in the same way. So let's connect all the 220 ohm resistors to the negative terminal of the LED and connect the other end of the resistor with a ground, which is to provide safety for the LEDs we are connecting. Right, so now I'm going to connect the resistor, that is 10 kilo ohm resistor, with a push button at one terminal of the push button. I'm going to connect a 10 kilo ohm resistor and then connect the other end of the resistor to, as usual, the negative side on the breadboard. So in this case we are going to use the push button as a pull down resistor, which we will be discussing at the later part of this video. So now I'm going to connect the positive and negative pins with the Arduino board. For that, so I'm going to take a wire, connect the 5 volt supply of Arduino board with one of the terminal of push button, that is the other terminal of push button, and then I'm gonna connect negative to the Arduino ground pin with the Arduino board. So we have given a positive and negative signal to the board. Now I'm gonna connect all the LEDs output pin with the Arduino board as well as the push button output pin to the Arduino board as well. So first let us connect the positive terminal of red LED with pin number 13 on Arduino, and the yellow LED's positive terminal with pin number 12 on Arduino. Similarly, the green LED's positive terminal with pin number 11 on Arduino. then I'm gonna connect the red LED of pedestrians with pin number 3 on Arduino, and green LED's positive terminal with pin number 2 and Arduino. So now we need to obtain the output from the push button. So I'm gonna connect the output pin of push button to pin number 7 in Arduino, so that according to the output from push button we're gonna operate all the LEDs. Alright, so that's it, we have completed the connection. Let's check out the output. So I'm going to connect the USB A to B cable, upload the code onto the board. You can see initially the green LED for the vehicles is continuously on and the red LED for the pedestrians is continuously high. So let's see what happens when I press the push button. So when I press the button, the light from the cars changes from green to red and the pedestrian light changes from red to green. After the cross time, the pedestrian green light flashes and changes to red. The light for the cars changes from red to green. So I'll do a demonstration once again. So if you are new to Arduino, it is better to change the value of some variables like cross time and change time and see what happens. Now, if you want something a little bit more challenging, try to mimic what happens in a junction with several lights for several cars and pedestrians. In order to understand the use of pull-down resistor, we need to see the working of a push button first. When you press the push button on, a small metal spring inside makes contact with two wires, allowing the electricity to flow, resulting in a 5-volt or digital value of 1. When the button is off, the spring retracts, contact is interrupted, and there is no current flow, resulting in a 0-volt or digital value of 0. Now, without a pull down resistor, that is the resistor which is connected to the ground, there will be a signal reflection in between the pins, which results in a floating input. Now let's check out the output to know it better. So here in this code, I have added a serial.begin statement in order to check the state of the push button in this particular line. Let's check out the serial monitor. So in this case, the output pin of the push button is supposed to provide either 0 or 1 to trigger the pedestrian LED. So initially the button is off. All you can see on the screen is a 0 value. Now I'm going to push the button and let's see what is the output we are obtaining from the push button. When I press the button, you can see an output value of 1 is being obtained. Now, by removing the resistor, the value fluctuates and we do not get a proper output. Let's check this out by removing the resistor. So I'm going to remove the 10K pull down resistor and it stops all of a sudden. We do not get a proper output. So the pull down resistor not only acts as a protector of the circuit but also mandatory for getting a proper digital output. So thank you guys, that's the end of this tutorial, and if you have any doubts regarding this session, you can always send your queries to futurebots@gmail.com. Let's meet again.